Hello. In today's video, we are going to see the probability density function and the cumulative density function for a continuous random variable. That is the PDF and CDF of a continuous random variable. The random variable will have a sample space which consists of infinite number of events. And usually the continuous random variables are described using a density curve as given in this diagram. So it will be any curve drawn above a horizontal line such that the area under the curve is always 1, because the area under the curve gives the total probability as in calculus. So the area under the curve represents the total probability, which is always 1. Now, in this diagram, we see a small event from the whole sample space. A small region is shaded. So that is just the event, because event is a subset of a sample space. And that area, that small area what is shaded, will give you the probability of that event. If it is shaded completely, that will be the total probability, but a portion of it is the probability of an event. A simple example for a continuous probability distribution is an example which is shown in here in this diagram. You have a density curve drawn above a horizontal line where the height of that density curve is 1. And since the length of this is also 1, this becomes a square. And if you're interested in finding the probability between 0 and 0.5, it is the first shaded region under the between 0 and 0.5, which is the area of the rectangle, which will be 0.5. And if you're trying to find the area between 0.8 and 1, which is the probability between 0.8 less than y less than 1, that will be the area, the small area shaded, which is 0.2. And in this, you have to note that the probability of y equal to 0.5 is exactly 0. Why is it so? P of y equal to 0.5. Y equal to 0.5 is the thin line drawn above 0.5. That area of a line, thin line, is always 0. So the probability when y is exactly equal to 0.5 is 0. It's mainly because of this reason. When you are trying to find the probability of 0 less than y less than 0.5, it is the same as the probability of 0 less than or equal to y and less than or equal to 0.5, because the equality will give you only 0. The probability for y equals 0 or y equals 0.5 is going to be 0. So it is immaterial whether you use a less than or equal to sign, or strictly less than sign, or greater than or equal to, strictly greater than equal to. It is not going to affect the result. So if you're trying to find the probability of y greater than 0.8 or y less than 0.5, you add both the shaded region. That will be 0.5 plus 0.2, which is 0.7. Let us take another example where you're picking a basket of onions. If x represents the number of onions and y the weight of onions in pounds, then the weight will be a continuous random variable, whereas the number of onions x will be a discrete random variable. The probability density function of any variable x is p of x equal to x, as in the case of discrete. But for a continuous distribution, we call that as a function fx, which is not the summation, it is the limiting case of the summation. We know that the limiting case of the summation is nothing but the integral. So it is integral a through b f of x dx. And also, it should satisfy the rules of probability, which is the total probability must be 1. In our case, the total probability will be integral from this extreme negative infinity to the other extreme positive infinity. F of x dx must be equal to 1. If you are looking for a cumulative density function, that is when you want to accumulate the function, that is p of x less than a will be integral from negative infinity to a of whatever function you have with respect to x. In a discrete case, you take the summation, whereas in a continuous case, you take an integral. Now let's take this example, where a continuous random variable is defined using the density function fx 1 over 26 times 4x plus 1 in this interval between 2 to 4, 0 otherwise. So you can draw that curve. See, the curve is given between 2 to 4. You can just graph 1 over 26 4x plus 1. Then the diagram will look like this. And if you're interested in finding the probability of 1 through 3, that is the same as, you don't have anything less than 2. So 1 through 3 is the same as 2 to 3. And that probability will be the integral of this between 2 to 3, which is 0.4231. If you are looking for a cumulative density function, according to the formula, it is from negative infinity to x, but my lower limit is 2, so it is from 2 to x of this 1 by 26 4x plus 1 dx. When you integrate and evaluate this integral, you get that as 1 over 26 2x squared plus x minus 10 in the interval 2 to 4. So that is this diagram. This line here between 2 and 4, is this 1 over 26 2x squared plus x minus 10. Above 4, it is 1 because it is cumulative, and less than 2, it must be 0. So in this case, this will be, your fx will be 0. Your fx is going to be 0 when x is less than 2, whereas 1 when x is greater than 4. Now if you take a density function where it involves a constant k times, it should be, I think, x plus 1, 3 minus x, in the interval 1 through 3 and 0 otherwise, you can easily find the constant k as k 5 by 68 by using the property that the total probability is 1. And what is the total probability in this case? The total probability is from negative infinity to positive infinity of f of x dx. But this is defined only between 1 to 3. In all other cases, it is 0. So 1 through 3 of k times x plus 1, 3 minus x dx. If you evaluate this integral and equate that to 1, you can easily get the constant k as 5 by 68. In this video, we learned about the probability density function and the cumulative density function for a continuous random variable. We also learned how to draw the PDF and CDF for a continuous random variable. Thanks for watching this video.